Second semester geometry. We're starting right where we left off in chapter 7. So here we go. Polygon interior angles theorem. We know that the interior angles of a triangle add up to 180 degrees. What we're working with now are larger size figures. And what we've come up with basically is this theorem. And you'll have kind of gone through this in the exploration, or you can read about it in the book. But the way it basically boils down to is that when I have more than 3 angles, the way we calculate the sum of the interior angles is by taking the number of sides, which is n here, minus 2, minus 2 times 180 degrees. So here I have a 6-sided polygon or a 6-angled polygon. So we would find the sum of the angles for all 6 angles is I take 6 minus 2 times 180. So 4 times 180, which is 720 degrees. So I know if I add up my angles and measure of angle 1 plus measure of angle 2 plus all of them, I can write this out. Takes a minute for equals 720 degrees. Now, obviously, that's my setup for an equation. As we've been doing all year long, we're going to set up and solve equations based on information. Usually in the past, we've added things up and set them equal to 180 or 360. Now that number is going to be kind of a moving target sometimes, but it's still the same idea. So if I knew what some of these measurements were, I could substitute those values in and set up and solve an equation pretty easily. Here's a figure. We want to know what the sum of the measurements is for this. And again, what we'll do is count the number of sides or angles. It doesn't matter. I have 1, 2, 3, 4, 5, 6. There are 8 angles here. So the sum is going to be 8 minus 2, number of sides or number of angles, minus 2 times 180. So that's 6 times 180, or 1,080 degrees, if I add up all those angles. Your turn. Got a picture of a loonie here. So why don't you find the sum of the interior angles of this in Edpuzzle. Go right ahead. We'll pause here. Now, solution, again, 11 minus 2 times 180, or 9 times 180. I don't have my calculator in my hand right now. Wait a minute. Now I do. But that'd be 900 plus 720, or 1620, I believe, is the correct answer. Let me double check that. Yep, 1620 degrees. Hopefully that's the choice you chose in the Edpuzzle. We could also work this backwards. If I know the total number of degrees in a polygon, I can find the number of sides. Now my formula is number of sides minus 2 times 180 equals the total. In this case, we know what the total is. The total is 900. Now mathematically, how are we going to solve that? Well, pretty simple. We're going to have to divide both sides by 180. So number of sides minus 2 is 900 divided by 180, which I believe is 5. Yes, it is. And from here, very simple to solve. Add 2 to it. So the number of sides is 7. So a 7-sided polygon has a sum of 900. Obviously, it has to be a whole number of sides here. This number cannot be a fraction. I can't have a 3.5-sided polygon or a 7.23-sided polygon. It has to be a whole number. If it gets something other than a whole number, one of 2 things happen. Either it's impossible, or you've made a mistake in your calculations and should go back and check. So if you get something that's not a whole number, make sure you go back and check and make sure that you've done your calculation correctly. And if you've done so, then you probably made a mistake somewhere. The corollary to this is about the exterior angles. I'm sorry, this is wrong corollary. Got to read what I got here. Some of the measures of a quadrilateral is always 360. That's going to help us. It's a shortcut. Obviously, we know a triangle adds up to 180 degrees. A quadrilateral always adds up to 360 degrees. And we could keep going. Pentagons are always 540. Hexagons are always 720. But the quadrilateral is the one we're going to be concerned about the most because we use that a lot. And that's just kind of a fact you want to keep in your hip pocket because we're going to use it a lot. So if we, four interior angles of a quadrilateral add up to 360. That makes problems like this really quite simple. Again, we simply add up the four angles, 108 plus 121 plus 59 plus x equals, and it's going to be 360 because that is a quadrilateral. And we just go ahead and do our math. I mean, the 108 plus 121 plus 59, that adds up to 288. And if I subtract the 288 from each side, I get x equals, what is that? 361. I'm doing this the old-fashioned way. Okay. So 215, 72 degrees. There we go. So my unknown angle is 72 degrees. Fairly straightforward stuff. Again, I give you the sum. You classify by the number of sides. So this is using our formula. The total is 1440, excuse me. So number of sides minus 2 times 180 is 1440. Have to divide by 180. And 1440 divided by 180 is 8. But remember, 8 is not my number of sides. I'm not done yet. That's the number of sides minus 2. I have to add 2 to that. That's actually a 10-sided polygon. So be careful. The most common mistake that's made here is that students get the 1440 divided by 180 equals 8, and they quit. Forgetting that's not the number of sides. It's the number of sides minus 2. The measures are of an interior angle of a quadrilateral, x, 3x, 5x, and 7x. Find the measure of the interior angles. And again, they're not numbers this time, they're all in terms of variables, but it's the same thing. I know that the four angles of a quadrilateral always add up to 360. So that's 10x, 16x is 360. So 360 divided by 16 is 22.5. So my angles are, now x is 22.5. That is one of the angles, but now I take that times 3 is 67.5 is another angle. And 5 times 22.5 is 112.5. And 7 times 22.5 is 157.5. So those are my four angles. And if I add those up, sure enough, they add up to 360. All right, looking at polygons here. Couple questions. We need to find whether or not this is a regular polygon and what the measures of angle C and angle E are. Let's first do the regular polygon thing first. We'll actually move this down to here, get that second. Is it a regular polygon? Again, reminder, what is a regular polygon? A regular polygon is one where all the sides are congruent and all the angles are congruent. This is clearly not a regular polygon because angles A, B, and D are all congruent. They're all right angles. E and C are also congruent, but they are not right angles. So since not all the angles are exactly the same measurement, that is not a regular polygon. No, not all angles are congruent. Now, you find the measure of angle C and E. Exterior angles. Exterior angles are the second part of this. An exterior angle, you can see in the picture here, is formed where a side intersects with the extension of a side. So like 2 here is an exterior angle, and 3 and 4, 5 and 1. We only take one exterior angle for every angle in the polygon. So it kind of creates a pinwheel type effect. But when I add up the exterior angles, and this is the interesting thing, it doesn't matter how many sides I have. The sum of the exterior angles, regardless of the number of sides in the polygon, is always 360. So the interior sum changes depending on the number of sides, but the exterior sum is always 360, regardless of the number of sides. And that's kind of interesting. So here I have 4 exterior angles. It doesn't matter that there are 4, other than that, that's going to help me set up my equation. What's the measure of the exterior angle? Say, wait a minute, I have 2 with variables. Well, yeah, but they're both x's, so we can still do it. X plus 2x plus 89 plus 67 equals 360. Why 360? Because the exteriors always add up to 360. Number of sides is not important. So 3x plus 156 is 360. So 3x equals 204. And x equals whatever 204 divided by 3 is, 68. And in this case, the problem just asks to find the value of x, and we've done so. Trampoline is a dodecagon. Dodec means how many sides? Yes, dodec means 12 sides. Find the measure of an interior angle and each exterior angle. Now, I'm going to give you a hint on a problem like this. The important hint you're going to want is start here. Start with the measure of each exterior angle. Because, and this is just kind of expanding in a general polygon situation, there's one angle of some polygon somewhere, and we have here an interior angle and an exterior. And I notice that no matter how many sides it is, no matter how it's going on, that the sum of the interior plus the exterior is 180. Now, interior angle, like we said, the sum is a moving target. It depends on how many sides you have. Exterior angles always add up to 360. So it's much easier to calculate the measure of each exterior angle in a regular polygon than each interior angle. So, and if I know the exterior, finding the interior is very quick because they have to add up to 180. They're supplementary. So what I'm going to simply do is say, all right, it's 12 sides. The measure of each exterior is the sum of all of them, which must be 360, divided by the number of sides, in this case 12. And 360 divided by 12 is 30 degrees. So each exterior angle is 30 degrees. Well, if each exterior angle is 30 degrees, interior plus exterior equals 180 because, again, straight line right down here. And obviously, if I subtract 30 from each side, each interior is going to be 150 degrees. So when you're looking for interior angles, it's usually easiest to find the measure of the corresponding exterior angle and just subtract from 180. Okay, that pretty much does our first lesson for Chapter 7. It's kind of a longer one, but the concepts here are not that difficult. We'll see in class and work on some of this stuff there.